So hi guys, today we'll be doing the topic of matrix multiplication. So I'm Alastair and this is my friend Elijah, and we'll be seeking to deliver a clear and concise presentation to help you understand the concept of matrix multiplication. So there are 5 stages to our lesson, and firstly we'll define and describe the multiplication of matrices. Then we'll provide the criterion for the multiplication of matrices. Then we'll try out different problems related to multiplying these matrices and then identify common misconceptions, then summarize this entire concept of matrices, like multiplication of matrices. So firstly, what is the definition of matrices? The definition is a very complicated one, but to put it simply, it is a binary operation that takes a pair of matrices and produces another matrix, and numbers such as the real or complex numbers can be multiplied according to elementary arithmetic. On the other hand, matrices are arrays of numbers, so there is no unique way to define the multiplication of matrices. And so matrix multiplication refers to a number of different ways to multiply matrices, and key features of any matrix multiplication includes the number of rows and columns the original matrices have, called the size, order or dimension, and specifying how the entries of matrices generate the new matrix. So the criterion for multiplication of matrices is that the number of columns in the first matrix must be equal to the number of rows in the second matrix. So how should we then multiply matrices?
Okay, right. So as Alastair said, there's a way to multiply matrices, but that matrices can also be multiplied by a real number, and they can also be multiplied by other matrices. So as for constant multiplication or real number multiplication, you can just basically multiply the matrix and all the terms in a matrix uniformly by the constant. In this case, the constant is 2, and we get this matrix as a result. Okay, moving on. Matrix multiplication. Okay, so here we have 2 examples. Okay, so here we have 2 examples. Okay, recap the criteria for matrix multiplication, which is that the number of columns in the first matrix is equals to the number of rows in the second matrix. Most people who do matrix multiplication use the run and dive method. Basically, the run and dive method is basically, okay, look, A times B is equals to C, wherein both A and B are matrices. So basically, the first term of C, we take AE plus BG. Okay, and to get a second term of C, we take AF plus BH. Okay, and then for the third term of C, we take CE plus DG. For last term of C, we take CF plus DH. Okay, so basically we can see that there's actually a pattern involved in that the product of the first for the first term of C, the product of the first terms of A and B are added to the second term, to the product of the second term of A and the third term of B. And this phenomenon is repeated throughout to obtain C. Okay, so we will be proceeding on to the various problems you may see in exams, and we will be teaching you how to solve them. Okay, firstly, problem 1. Given the values of matrices P and Q, find K if PQ equals to QP. Okay, do bear in mind that in normal matrix multiplication, PQ should not be equals to QP, not necessarily equals to QP. Okay, so on to a question. Okay, so basically the first matrix we have here is actually PQ. As you know from your run and dive method, you basically sort out each of the values for each matrix. So this is PQ and this is QP. And because from the first, second and fourth terms of each matrix, we can't really derive any value of k because the coefficients are 0 for first two terms, and for last term we get 4k and 4k, from which we cannot deduce anything. Okay, right, so from the third term from the first matrix we get 6 plus k, and from the second matrix we get 9 plus 8. So therefore, since PQ equals to QP, 6 plus k must be equals to 9 plus 8, and therefore using linear calculations, k is equals to 11. On to the next problem. Given the value of matrices P, Q and R, find the unknowns A, B and C as well as D when 2P plus Q equals to 3R. Okay, so the first step I took to solving this problem was to find 2P. So basically 2P, as I said just now, is basically multiplying matrix B by the constant 2. And so after that you get this 2P matrix. And after taking 2P plus Q, which is matrix addition, which you have learned previously, you will get this matrix over here, which from the question is equals to 3R, which by constant matrix multiplication, from which we get this. Okay, afterwards, tallying up the different terms in both matrices, we get these values. From the first terms, we get 6 plus 2a is equals to negative 9. And from the fourth term, 3b minus 4 is equals to negative 18. From the second term, 8 is equals to 3c. And from the third term, 6d is equals to 7. Using simple algebra, we can find the values of a, b, c and d. There are several misconceptions which students may have when they conduct matrix multiplication, which is, as I have previously said, AB is not equals to BA, and matrix multiplication is not the same as constant matrix multiplication. So ABCD matrix multiplied by EFGH matrix is not equals to this matrix over here, because in this matrix over here there is no such order which I have talked about in matrix multiplication, and there is also no addition involved. Okay, so for a summary and recap.
So in short, AI equals to IA, and which is equals to the matrix A, and the matrix A times matrix B is not equals to matrix B times matrix A, and so the order does matter. However, because matrix A times matrix B times matrix C is equals to matrix A times matrix B times matrix C, because the order here is same. And the criterion for matrix multiplication is that the number of columns in the first matrix is equal to the number of rows in the second matrix, and the order for the resulting matrix AB is given by the number of rows in the left matrix, which is A, and the number of columns in the right matrix, which is B. And remember to run and dive to solve your matrix multiplication.